Okay. So if there is no one saying something, then I'm assuming that everyone is able to see my screen. Now, the topic is cost estimation and the interpretation. So cost estimation and interpretation. So it is a continuation of what we did in AMA and the topic of cost forecasting in AMA. Yes. So cost estimation and interpretation. And interpretation. That one is okay. So what cost estimation and interpretation. Now we can start from the basics. And the basics are we remind ourselves what is the meaning of the word cost from what we did in the previous level. And we introduce some other new concepts that we need to study. But let us remind ourselves for the purpose of illustration. So let us define what is a cost, because we need to know the meaning of the word cost. So when we talk about a cost refers to economic resource used in production. So a cost is an economic resource used in production. It's an economic resource used in production. That is the simple definition we can use, which is expressed in form of money, which is expressed in the form of money, in terms of money, in terms of money. There's another definition also on cost that it is very popular, and that one is sacrifice made to acquire goods and service. Sacrifice made to acquire goods, to acquire or purchase goods or services. So it's not necessarily we argue in terms of production, but we can also argue in terms of when we purchase a good or a service Now, for the purpose of advanced MA, we shall focus on various classification of costs, not all that we did in MA, but we shall focus on only two classifications. So classification of costs that we shall need in this topic or in this MA study. So classification of costs, we had a lot of classification. So we had classification according to relevance, according to availability, and so on. We had classification according to what behavior, according to product. But for this purpose, we shall focus only on two classification. Number one, classification according to activity level. According to activity level. You remember what is activity level from our previous study? Now, what did you say was activity level? Now, when you talk about activity level, refers the number of units produced and sold. Refers the total number. When I'm doing a mute. So we are saying, when we talk about activity level, we are talking about the number of units produced and sold. So it measures the number of units produced and sold. And in short term, we can call it productivity. So measure of productivity. Now productivity is the number of units that we produce and sold. Now we can define it as measure of productivity. Measure of productivity of a farm, i.e. number. So it is the measure of, number of units produced and sold. Produced and sold. Number of units produced and sold. So that is the easiest definition we can use if we want to define activity level. Now, let us see some of classification according to activity level. Number one, we have the fixed cost. Remember, these are costs which remain constant. They do not change with the level of activity. So when the level of activity changes, or even when you produce more units, the cost will remain the same. So we can say this is the cost whose total does not change. This is the cost whose total do not change with change in the level of activity. With change in the level of activity. The level of activity. The level of activity. That one is fine. It is usually expressed as a single amount, single total amount. It is always expressed as a single total amount. As a single total amount. So remember, that one is a single total amount. So when you talk about fixed cost according to level of activities, even if we intend to produce more units, the fixed cost will remain the same. It will not change. Number two, we have the variable cost. Variable cost. Now, what is a variable cost? Now, when we talk about variable cost, we mean that this is the cost whose total amount will change when we have some variations when we change our level of our activities. So when the level of activity changes, automatically the variable cost will also change. So the variable cost will also change. So we can write and say, this is the cost. This is the cost whose total amount changes. Whose total amount changes. Whose total amount changes in direct proportion. Indirect proportion So in the direct proportion of what? As activity level changes. As activity levels changes. As activity level changes. Now, it is usually expressed in what form? It is usually expressed as per unit basis. Remember this one here, it is expressed as a single total amount. In this case, it is expressed as a cost per unit basis. The keyword here is the word per unit basis. Cost per unit basis. The last one, under activity level, we have the mixed or the semi-variable. Mixed cost, or also called semi-variable. Semi-variable cost. And these are those costs which have some elements of both fixed cost and the variable cost. Now you can say these are costs which contain both fixed and variable cost. So these are costs which contain both fixed and variable cost. Variable cost. And in our previous class, in intermediate level, we saw that when we are talking about mixed cost, the good method to be used to analyze our cost is the account analysis method. Remember the account analysis method, we were differentiating between fixed cost and variable cost in order to come up with the cost predictor equation. So when we have the element of both fixed and variable, or the mixed cost or the semi-variable, so the best method to use to come up with the cost predictor or predict cost is the account analysis method. Remember the account analysis method? I hope everyone can remember that one. I hope everyone can remember that one. Now, it is mostly used in account analysis method. It is mostly used in account analysis method. This is one of the methods of predicting cost. So that I will not talk about it because you remember from your MA, the account analysis method. Sometimes you can also use the high-low method in such kind of a scenario. But for now, that is all about classification of cost according to the activity level. We can also call it cost behavior, according to cost behavior sometimes. So in MA, they call it cost behavior. So here you can call it activity level. So we talk about cost behavior represents how costs tend to change when the number of units keep changing, which is the same as when we keep on changing our level of activity, then some costs will change, others will not change. Now that is classification number one. Classification number two, which is also very important in this topic and other topics, classification of cost according to product. Classification of cost according to product. Classification of cost according to product. So what are those costs? Someone remind us from Amy? So classification of cost according to product. So number one, now we talk about direct and indirect cost. So direct and indirect cost. We shall not dig inside. We shall just focus on direct and indirect. Remember, for direct, we have direct material costs, we have direct labor costs. For indirect, we have other overheads, So we shall not talk about all those. We shall talk about direct and indirect as a general classification, but we shall not dive inside. So direct material, number one. Direct material. Not direct material, cost. Direct cost. We shall not dig inside. So under direct cost, we have items such as direct material cost, direct labor cost, and other costs. Now, I will focus on direct cost in general. And we say these are costs which can be clearly identified, or can be clearly identified with the product. So these are the costs which can directly be identified. Costs which can be directly be identified. Costs which can be direct costs which can be clearly, let's do the word clearly. Costs which can be clearly identified. The word clearly here. Clearly identified with the product. Costs which can be directly or clearly identified with the product. Or these are costs which can be attributable. You can also say it that these are costs which can be attributable to a product, to a particular product. Costs which can be directly be attributable to a particular product. For example, ukiamua kutengeneza kameza, aka kameza kitu ndio yako hapo. Na aka kameza sijui kama mnakaona. Aka kameza ndio tukatengeneze, we need the mbao. So mbao is the main product of this meza. So we can say that mbao is the cost which can be identified to the product. So tukiona mbao, we can know the amount of this meza. But kuna other items hapa ndani which hatuwezi jua. So we have tumishumari tumepigiliwa hapa ya kushikilia. Na unato mishumari unaweza pata alinunua kilo moja akaunda meza ine. So we cannot say the exact amount of mishumari. So that is what we call the indirect cost. Cost which cannot be directly identified with the product. So mishumari yes ilitumika kutengeneza, but unaweza pata alinunua kilo moja akatengeneza meza tano. So we cannot say that hizo meza tano the exact cost of those mishumari ni gani from one meza. So in that case we call it indirect cost. Now when we talk about indirect costs, these are costs which cannot be clearly identified with the product. Costs which cannot be clearly be identified hapa kuna kati identified with the product. Cost which cannot be clearly identified with the product. We call it indirect cost. Now that is what we did in MA. We are not interested so much, but we need to remind ourselves because we might need those items as we progress. Now, let us talk about cost forecasting. So allow me to rub. So any question before ni rub? Anyone mwenye hajaandika? Because I'm okay. Now I'm assuming everyone has managed to write. So let's talk about cost forecasting. Cost forecasting. So we want to do cost forecasting or cost prediction. So how do you predict costs? Yes. How do you predict costs? So for us to predict cost, we need to talk about the element, not the element, but rather we need to talk about cost forecasting. So we need to talk about cost forecasting. Cost forecasting. So let's talk about cost forecasting. Now, what is cost forecasting? Cost forecasting. When we talk about cost forecasting, we are talking about effort made to determine in advance the expected amount of cost. So you can say refers to efforts made in advance, refers to the effort made in advance to determine the expected amount of cost. The expected amount of cost. It is done by developing a predictor equation. It is done by formulating or determining predictor equation. Predictor equation in form of y is equal to a plus bx. Y is equal to a plus bx, where y equal to total cost, a fixed cost, and then b variable cost per unit. Variable cost per unit, and then x is the level of activity. Level of activity, or the activity level, or the activity level, or the activity level. That one is okay. So that's a predictor equation we shall use. Now steps used for prediction purpose. So steps. Now this one I'm going to dictate. Number one, identify cost to be predicted. So right, identify cost to be predicted. So identify the cost to be predicted. This cost is the dependent variable y. So this one, so tunasema identify the cost. So step number one, identify the cost to be predicted. And then we say this is referred to us as dependent variable. Referred to us as dependent variable. It is referred to as dependent variable. So that one is referred to as dependent variable, represented by letter Y. Represented by letter Y. So that is step one. Identify the cost to be predicted, full stop. This is referred to as dependent variable. Is referred to as dependent variable, denoted by letter Y or represented by letter Y. Step number 2. So in case utakuwa umesikia, just put a message kwa chat box, then itaangalia. Step number 2, identify the cost driver. Identify the cost driver. Now, what do we say are the cost driver? Cost driver from our intermediate level. So step number 2, we identify the cost driver. Cost driver. Remember, I talk about cost driver. These are costs which comes in because of particular factors which unaweza ziko. For example, if the number of units increases, cost might increase. So that unit increase is a cost driver because it has drive the cost to increase. It has drive the cost to increase. So we are saying step number 2, identify the cost driver. Let us define it. This is a measurable factor whose changes make the cost to change. This is a measurable factor. This is a measurable factor whose change makes the cost to change. That one is very fine. So we talk about cost driver. We are talking about those measurable factor or measurable units that will make the cost to change. And a good example to measure the number of units X. When the number of units X increases, it will drive the cost to increase. And therefore that X, because we can measure the amount of the value of X in terms of cost. So for example, the number of units may increase, we can say that the increase of maybe 2 units, it will find a cost increase by 200. So that 200 is a measurable number from the X units. And that we can call it a cost driver. So any measurable factor or any measurable unit which will make the cost to change, we call it a cost driver. And then we say it is represented by independent variable. So this one, you continue and write, it is represented by independent variable. Independent variable represented by letter X. So cost driver represents the dependent variable, which in the Yaba X. So it represents the independent variable represented by letter X. So it represents independent variable represented by letter X. So to model number 1, we identify the cost. The cost predictor, the cost which is represented by Y, then which is the dependent. Then we have the cost driver, which is represented by the independent variable. Step number 3, gather data relating to X and Y. So we're doing a variable X and Y. So one is total cost, the other one is the variable cost in our case. So step number 3, gather data relating to variable X and variable Y. So gather data relating to variable X and variable Y. That is all. Step number 4, plot the data on a graph and identify the pattern. Step number 4, plot the data on a graph. So plot the data on a graph and identify the pattern formed. So step number 4, so once you have identified the data, you have gathered the data, you have it, you can decide to plot it in a graph. So, and then you identify if there is any pattern that you can see which relates to X and Y. So any pattern, it can be direct relation, or it can be inverse relation, or it can also be no relation at all. So when we plot and we tend to identify the pattern, we are trying to see if we have any direct relation or any indirect relation, or there might be no relation between the variables. Step number 5, which is the second last, develop a cost function in form of y is equal to a plus bx. So develop a cost function which is in form of y is equal to a plus bx. And you know y is the total cost, a is the fixed cost, b is the variable cost per unit, and then x is the number of units if you are talking about cost. So step number 5, develop a cost function. Develop a cost function using appropriate method in form of which shall be in form of, we are saying develop a cost function using appropriate method. Develop a cost function using appropriate method, which might be in form of y is equal to a plus bx. And then ya mwisho, which is very, very important, and that one will be our focus in topic 2 in most cases. This is what we should focus. The last step, test the reliability of the equation. Step number 6, test reliability. Step number 6, test reliability. Test reliability of the equation. Test the reliability of equation. Now, when you talk about reliability, we are trying to talk about how well can we rely on that equation. Is the equation making any sense? Now, if it is making any sense, then we can rely on the equation. So we have various tests for testing reliability, of which we shall do it later as we progress before the class ends. So we have various ways to test reliability. So is the relation, not the relation, is the equation making any economic sense, or can we rely in that equation to predict? So that is how we shall test. And we are doing the reliability test because within these processes, before we reach to the last process, we might make an error. And therefore, we need to test if our equation can be relied. So is there any differences between what we expect and the actual results that we may obtain? So we need to do what? To test. And that one is also, it also applies in real life. So it also applies in real life. So for example, if you are in a relationship, now, is the relationship reliable? Is the relationship reliable? Having been given, or maybe inaweza kuwa ndio umepeana some promises, or the other party amekupatia some promises. So is the relationship reliable? So till death do us apart. Now, is that relationship reliable? Now, within the process, then you might end up seeing maybe some factors which might make the relationship not reliable in the process. So we need to test the equation to know if we can rely on such kind of equation. So that is what we call the reliability test. Now, methods used in forecasting. Method used in forecasting. Method used in forecasting. So allow me to do away with this one. So this pen ya black inachafua nini sana board. So I need to rub it twice with another. So inachafua haraka. This black pen. Now, what are some of methods? So let us state them. So methods of forecasting. So method of so number one, method of cost forecasting. So let us set them. Industrial engineering method. We did it in MA. Industrial engineering method. So we shall not focus on this one. Maybe the one two notes, kidogo, but you remember what it's all about. So it is based on level of experience and skills. For now, you have the account analysis method. Also, we did it in MA. Account analysis method. We also did it in MA. So we shall not focus so much on that. Also, we have the high-low method. We can also not focus so much on that, but remember, make sure you know how to do it. High-low method, because you can find a question on those days. So in the case of Kumbuki, you make sure you revise it. Now our focus will be on these last two: regression analysis, where we have the single and multiple regression. In the multiple, this will be our focus. So mostly we shall focus on multiple. The single haina mambo mingi, but we shall also talk about it kidogo. Then ya mwisho, this one is very, very important. This one, you can find a question in learning curve from any topic, from topic 1, from topic 2 to the last topic. You can find a question on learning curve. So they can combine another topic with the learning curve. So this one is very, very important. This one is very, very important. The learning curve. So we shall focus with the last two, the regression analysis and the learning curve. The rest, tutapatiana notes baadaye. These are the first two, 1, 2, 3, and 4, because at least you have the idea, tutarudi baadaye. Now, let's go to regression analysis method. Regression analysis method. So regression analysis method. So regression analysis method is what, that's our focus. That is our focus. And it is very, very important. So make sure you are very keen with this one. So make sure you are very keen with this one, because you shall also use this information to do interpretation when you shall be doing your BDA. So sisi tutajifunza ku derive them manually, but when you be doing BDA, you shall derive it using an Excel, so inakupatia answer direct. But it's good to know it manually because it will help you for interpretation purpose. So for BDA, when I test your interpretation purpose and you know how to come up with the figures. So for this now, we shall come up with the figures manually and also interpret it. So regression analysis method. Now, regression analysis represents statistical method. So represent the statistical method. So represent statistical method used to study nature and strength of relationship between variables. So represent statistical method used to study nature. So used to study nature and the strength and strength. So you also did this one in QA, and strength of relationship between variables variables. Now, when we talk about the nature, we are talking about is the relationship direct or indirect. Now, when we talk about the nature, what we are trying to say is the relationship between variables a direct or indirect relation, or is there any relation between that variable in terms of direct or indirect? When we talk about strength, we are talking about a strong positive or weak positive, or you know those items. So we have the weak correlation, we have a strong correlation. So when we talk about strength, we talk about correlation. So is the relationship having a weak correlation or a strong correlation? So it can be positive correlation, a strong positive correlation, or a strong weak correlation. So this one talk about the strength or the magnitude. So we can also term it strength of the magnitude of the relationship. Magnitude. And this other item talks about the general direction, general or the nature. Positive relation. So when X increases, Y might increase or might decrease. That's just the general. This one talk about the correlation itself, the strength. Now, we have two types. We have number one, single, a simple. We use the word simple, regression. And number two, we have the multiple regression. Now, we did a single in MA, so we shall come back later. Let us talk about those that are Fanya, because the rest we can do it very easily if we find a normal time. But for now, let us stick on multiple regression. Now, what is multiple regression? Now, when you talk about multiple regression, so let us talk about multiple. For single, we did in MA intermediate, but so we shall come to it later because we don't have any question in advance. Or I think we have only one question for single, only one. So the rest are under multiple regression. So this one, most questions go for intermediate, of which we can visit only one question to remind ourselves in case you find it in an exam. But we shall concentrate on multiple regression. Now, from your MA, you remember when we talk about simple regression, it is where we have only two variables, one independent variable and one dependent and one independent. This one, y is equal to a plus bx. So this one is for simple. We only have two variables, variable y and x, where one of them is dependent, this one. So y depend on x. So y is the dependent. The other one is independent. So in simple regression, this is a regression analysis where we already have two variables, Now, when we talk about multiple regression, this is a regression where we have more than two variables, meaning, okay, let us write it down first. We say this is where we have more than. So this is a regression analysis where you have more than one independent variable, where we have more than. So ukisema more than one, unasema independent. Lakini kusema where we have more than two variables ni kumaanisha both x and so it is you, but mimi natumia, so this is a regression analysis where we have more than one, but remember the keyword is the word independent variable. And remember our independent variable is x. So in case where you have more than one independent variable, we call it a multiple regression, i.e. y is equal to a b1 x1 b2 x2 up to bn xn. That's a very good example. That's a very good example that we can make use of. That's a very good example we can make use of. Now, how do we explain this equation? Now, when one factor change, how will it affect y? Remember, you need to make the other variable constant. So i.e., I will just give you one. When x1 changes with 1 unit, y will change with the same margin, with the same, let us do that, with the same proportion, holding other factor equal or constant. Now, when we want to vary variable x, so if you want to vary variable x1, so when you want to vary variable x1, we can say, so when x1 changes with 1 unit, y will change with the same proportion, holding the other factors equal or constant. Holding the other factors equal or constant. Now, if we want to vary variable x2, then we shall say when x2 changes with 1 unit, y will change with the same proportion, holding the other factors equal. So holding the other factors equal. Same if you want to vary variable xn. So when xn changes with 1 unit, y will change with the same proportion, holding the rest of the factor equal. Holding the rest of the factor equal. So that depends on with you. Now, when you are doing analysis, you do analysis at one variable at a time. So if you want to do an analysis for x1, you start with x1, holding the others constant, and so on. So that's all about just some definition that we can find for regression. Now, for the purpose of MA, we cannot be told to find this value, B1, B2, Bn, the slope. It is very hard. What they do, they shall give you the information and tells you to explain. Now, how does they give you the information? So we jump in to the reliability test. So let's talk about reliability test. So that is what is very reliability test. So let's talk about the reliability test. Reliability test. Let us talk about the reliability test. Mtako na swali? So kama mute. So let's talk about the reliability test, and that one is very, very important, and that one will form the basis of everything that we are doing now for this topic. Then later, if time will allow, we shall do learning curve. So the two of them are very important. Now, without wasting any time, let us jump in to the reliability test. Let us jump to the reliability test. So it is advanced. So reliability. Reliability test. That one is our focus. Now, this one is very, very important. Now, when we talk about reliability test, what do we say? We are trying to test the accuracy of the equation. Can we relate to that equation? So we are trying to test if the equation is accurate. So we are trying to test if the equation is accurate. And this one is very, very important. So mkue makini hapa sasa. Hapa tusipokuwa makini, tutatoa swali afu itakuchanganya. So those who have done statistics will have an easy time. But kama hujafanya statistics, then you need to concentrate more. So let us see. I want us to be very, very fast. Yes. Hiyo bodi inachafuka sana. Now, when we talk about the ability test, we are talking about these are tests which confirm the accuracy of the equation. So these are tests which confirms the accuracy of equation. So these are tests which confirm the accuracy of which confirms accuracy of the equation and how we can be able to depend on such relationship. To depend on such relationship. Now, if you are in a relationship, there is also a need to confirm the accuracy of that relationship so that you know if you can depend on such relationship. Now, how does you confirm the accuracy? So maybe by making sure you interact so much with the other person so that you know their ideas and their stake on life, so that you see if you can depend on that person. So that one can be also a good measure of accuracy in a relationship. So you cannot find a person, if you are a man, you cannot find a woman maybe in a day, and then you propose to that woman and say that you want to marry them. So you need to take your time so that you can determine the accuracy of that relation. But remember, there's something else I want to say. It does not necessarily mean when you investigate so much on a particular relation that you might find the accuracy of that relation. So we cannot say it is 100% or a particular percent. So you can find someone, find just someone the other day, and they get into a relation, and the relation becomes of success. But they have met just the other day, or maybe wakati walikutana for a very limited period, then waka progress on other things. So that one does not necessarily mean that when you take more time or when you have more information will make the relation accuracy. Same applies here. We might have our data or our information, and we might have more information concerning that data, but the test might not give the actual accuracy of that relation. So that one is something you need to know. But it might help you at some extent to determine how accuracy. It cannot be 100%, but at least it can give you the kind of relation. Now, when you meet someone along the road, or when you meet your friend along the road, you cannot say what this person is thinking inside his or her head. But with the way you have interacted with that person, you can have a conclusion on accuracy of that person when you are together. But you cannot know what that person is thinking inside. And therefore, we cannot say that the relation is 100%. But to some point, we can say that we can rely to that kind of an equation. Now, the test includes the following. So the test includes the following. Number one, which is the best? It is called economic plausibility test. Economic plausibility test. Now, economic plausibility test. This test is done to confirm the following. So we say this test is done to confirm the following. To confirm the following. One of them, now it can be used to confirm, number one, logical defensibility. Logical defensibility. Number B, economic sense. This is what we use to confirm economic. Is the equation making any economic sense? So is the equation making any economic sense? Now, this is what you need to know. When you talk about logical differentiability, now remember, if you have a particular equation, y is equal to a plus bx plus bx1, and so on. Now, in a particular situation, x will have some effect on y. What will happen when the condition change? Will the same x have the same magnitude y? Now, if the changes in circumstance will not affect the change in y, we can say that the equation is logically differentiable. So regardless of changes in circumstance, the value of y will affect, the value of x will affect y in the same manner. It will not change. That's what we call the logical differentiability. Now, we'll talk about economic sense. Now, for economic sense, let me give you an example. This one is a very good example. And I want someone to tell me when you have, let us say, maintenance cost, which is y, is equals to 17,000 plus what? Usage. So plus 200 usage, which is usage of machine, which is X. Now, someone to tell me, what do you expect when the usage of machine increases? What do you expect with the cost? Yes? Wacha nitafute mtu randomly. Hapa naona kuna mtu anaitwa Emma. So what do you expect? So when we use the machine sana, what do you expect about the maintenance cost? Yes, someone ametype. Yes, we expect that the cost will increase. Now, remember we have what we expect. So we expect a direct relation. Now, once you do your test, then you find the actual, what now you get is negative. So remember, we are expecting when the usage of machine, when we use the machine that much, itafika mahali machine inaweza kuharibika, so maintenance cost will increase. Now, that is what we expect. But when we do our actual test, we find now here, tupate ni negative. Hii ni kumaanisha, when we use the machine, the maintenance cost reduces. Tupate hapa ni negative. Ni kumaanisha, the equation is not making any economic sense. It's not making any economic sense. So you can comment and say, kama ungepata that is your final analysis. Umepata this is your final analysis. You can conclude and say the equation is not making any economic sense. The equation is not making any economic sense. Now, what if ungepata sasa ni positive? So we expect positive. Now umepata positive. Then we can conclude and say that the equation is making economic sense. So that's how we can explain. Number one, logic differentiability. Can the equation defend itself in various circumstances? If yes, then we say the equation is logical. Number two, does the equation making any economic sense? If yes, then we say the equation is economic plausibility. For now, that one is what we need. Let us write it down. We say an equation is logically defensive. An equation is logically defensive. So let us write an equation is logically defensive. An equation is logically defensive if it remains unchanged, even when the circumstance changes. So the equation is logically defensive. So the equation is logically defensive. So the equation is logically defensive. So the equation is logically defensive if, so the equation is logically defensive if it remains unchanged, even when the circumstance changes. Even when the circumstance changes. That one is for logical. Number two, an equation is said to make economic sense. An equation is said to make economic sense. An equation is said to make economic sense if it is in agreement with what is expected. So an equation is said to make economic sense if it is in agreement with what it is expected. If it is in agreement with what it is expected, if it is in agreement with what it is expected. Let us go to our past paper, August 2024. So tunafanya kidogo kidogo tukijaza. So tutakuwa tunafanya tu kidogo kidogo tukisonga juu ya time. So August that's sitting. So August 2024, make sure you open your past paper. Nilikuwa nimeshare kwa group. So mwenye a comment hapo, I reshare back again to the group. But I think everyone is in the group. You did manage to find. But if you don't have, you can comment and I will share immediately. Or someone else can also share in the group. Someone else can also share in the group. But I think that one is okay. So August 2024, question number, it is 2B. Where is that group? Let us open our past paper. So which sitting here is that? August 2024, question number 2B. So August 2024, question number 2B. And in specific, I want us to answer part 5. Part 5. Because hizo zingine tujafanya, tunafanya pole pole. So ni mingi. So the test ni mingi. But I want us to see if the equation is making any economic sense. Now, can you see it? Question number 5. Question number 2B, part 5. Can everyone see it? Now, let us read the question. Now, before you start doing this question, one thing you need to know is to identify the variable, you need to identify the dependent and independent variable. That is very, very important. Now, before even you progress to this question, you need to determine which one is dependent and which one is independent. Which one is dependent and which one is independent variable. That is very, very important for the purpose of illustration. Now, so let me read the question as we interpret. Plasma Electronic Ltd supplies digital decoder and liquid electronic display set for high-end users. Customer contract Plasma Ltd with the request for maintenance for the terrestrial signal frequency. To estimate the service cost, Plasma Electronic Limited wish to predict the installation in hours that is dependent. Hata amefanya mzuri kutuambia. So some question atakuwa amekuambia, but this one ametuambia. So we have the dependent variable, which is why wanasema ni nini? Wanasema ni installation time in hours. Installation time in hours. Number 2. Not number 2. Necessary for maintenance request. Installation time is believed to be related to 2 factors. Now, which factors affects why? So we have the independent variables. So only 2 factors. So mention this one is a multiple regression. So it's a multiple regression because we have 2 factors. So treat x1 and x2. Now x1, we can pick it as number of months. Since, so this one is number of months since installation. So number of months since installation. So number of months since installation. Now you get a type of maintenance. 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 Now, what do you expect? Now, what do you expect when the installation time is long time ago? Now, let us assume we installed this item 20 years ago. So what do you expect when you talk about maintenance? Now, if we install this machine long time ago, we expect that we shall have more maintenance from time to time. Serial. Now, if we install the other day, come to install Jana, we expect no maintenance. So we have that relation. So when the number of installation time increases, we expect that the maintenance will also increase. Serial. Now, for example, if we install this machine 20 years ago, what do you expect? You expect an increase in maintenance. But if we installed it maybe 1 year ago, we expect minimum. So when the number reduces, maintenance also reduces. When the number of years of installation increases, we also expect maintenance to increase. Is that correct? Yes, yes. So now what about the number of month? The number, where is it? The number of month since last installation. What's the relationship? Now, if the number of months before installation ni mingi, ni kumaanisha what will happen to installation time? We shall have more installation time. Sivyo? Kwa sababu kama assume the installation ilifanyika, so the last time tulifanya installation ilifanyika 20 years ago. So if that person was to come back to do some installation, we require more time. But kama ulifanya installation jana, afa akuja leo tena, ni kumaanisha anakuja kuangalia kitu kidogo, maybe kulikuwa na kitu kidogo na anamaliza haraka. So that also has a direct relation. Now what we do is this. Let me show you how we answer this question. Haraka. Now this is what how we answer. I will use this format. So make sure you have a big space, dependent variable. Then we talk about dependent variable. So we are answering part 5. This is the answer. Independent variable. Yeah. We need to find the expected. What do we expect? Then actual. Then the last one we do what? We comment. Then the last one, we comment. Now, in this case, we have only 3 variables. Now, the first one, we have the first dependent variable ni moja tu. We have y, which tunasema ni installation cost. So mimi naweka y, so nimeweka y, which is installation time. Independent, we have x1, of which is the number of months since last installation. What do we expect? What's our expectation? We expect direct so we expect direct relation. Now let's go to our question. What is our actual from the table? Now we go pale juu kwa regression analysis. Let's go to our table pale. So we need to come up with our equation, predicted equation. So we go pale kwa regression analysis pale juu, table ya kwanza, regression analysis. Now, can you see the word coefficient? Can everyone see the word coefficient? Yes. The word coefficient?
Yes.
Now, yes. We have A. So tumesema our equation iko na how many variables? Tatu. Y, x1 and x2. B, x1 plus B, B1 na B2, x2. Now, A, B1 and B2 are coefficients. So remember here the coefficient. So A, B1 and B2 are coefficients. So unaenda kwa regression analysis, unaangalia coefficients. Na kumbuke A ni intercept. Ukumbuke A ni intercept. Aya. Let us come up with the equation, which is our actual from the analysis. So itakuwa ni y is equals to, so A ni constant on the intercept. The first one, the constant, 0.93, 0.50. Then the other one, so you see the man, 0.38, 762, x1 plus, now from this equation hatujapatiwa the figure of x2 of b2. Now we need to find the b2. Let me show you, but tutaifanya baadaye also, but because hiyo wamekosa kupeana, let me show you how to find it. So you could be very keen, but tutairudia tu baadaye. We shall repeat it later. Let me show you how to find B. Wanasema B? To find the B2 from our equation. Now look at our equation. I want to show you something. Do you see the T? For analysis, nyuma kabisa huko kando penye we have XA. Do you see the T? Do you see the T?
Yes, yes, we are seeing it.
Now T, that's the T calculated. Sivyo? It's called the T calculated. So how do you find the T calculated? This is how you find it. Is equal to coefficient of estimate. We divide it by the standard error. Standard error. So S inaonyesha standard error of the coefficient or the estimate. So the first one, together a constant. Do you see the constant? Now, if you were to find T is equals to, so XA, just let me show you. For you to find A, coefficient of the estimate is 0.93, 0.50. We divide by 0.367. 3670. So what will be your T? T calculated. So you need to find XA. That one is how to find XA. Takuwa ngapi?
2.54.
2.55354. 2.3, 2.53, I mean, 5354. Mwana hiyo? Now find for me XB. Find for me XB. once you know this information, T calculated, so T inamaanisha T calculated, so inamaanisha T calculated. T calculated. Now, Jane, find for me XB. Then jamaa wetu hapo mwenye akona base atupatie C XC, which we need it here. So our XC ndio our B. So we need it here. Now, someone find X. Tutafutie hiyo kwanza XB. XB. Now, tumesema XB tutapataje? Now, XB already we know 6.20 is equal to what? We have the T calculated. So what is the coefficient? 0.38762. We divide it by XB. So what will be our XB? What will be our XB? What's our XB? Yes. Can you Andrew? I'm a captain.
0.0625.
0.0625, yes. So 0.0625. But we shall explain this more pale mbele. But because this one hatuwezi to capture, that's let us do it as we move on. Aya, huyo mwingine ilikuwa nani? Ilikuwa ni Jeff. So Jeff anafaa kutuambie XC. Ifanyie hapa
1.2627.
XC msema ni
1.2627. Yes.
Yes. Nasema ni 4.02 must be equal to what? XC over 0.3141. So kumaanisha you multiply this one with, so utapata hiyo 1.2627. 26227. Aya. What else? Now, tukuja hapa, let us complete our equation. 0.93050 plus 0.3876 plus. So hiyo itakuwaje? Plus ilikuwa which figure? Which figure did we wanted from that one? It was XC.
XC.
1.2.
1.2627.
X2. Now, what is the relationship between, so our actual here? So remember tuko kwa X1. So what is the relationship between X1 and Y from our actual? Our X1, so about we have positive.
Direct.
So that is direct. Direct, which is positive. Now, what's our comment? The equation is making economic sense. So you can say the equation is economic plausibility. Now, we go to the next variable, which is our X2. So we have Y as our dependent. We have X2. Now, what do we expect? We also expect that the type of machine that we shall use is direct proportion to the time of installation. So we can say it's also direct. We also expect direct relationship, which is positive. Now, hapa, our actual is also, so our actual ni ngapi? Is it positive? Our action is still positive. Now, what is our comment? Our comment is the same. The equation is economic, or you say the variable. Let us not use the word equation. Let's say we say x1, now x2. So x1 is economic prosperity when you compare it with y. So x is economic. So x1 is economic prosperity, and also x2 is economic prosperity. Now, because we tumejaza hizo vitu, let us go to part 1. Write down the linear regression equation.
Excuse me, sir.
Yes.
I have a question.
Yes.
Kwa swali yetu hiyo part ya installation time.
Yes.
Is believed to be related to 2 factors: the number of months since the last maintenance service and the type of maintenance problem, whether digital or analog. Hiyo part ya mwisho hai make any impact.
Ya mwisho gani hiyo?
Whether digital or analog.
Ndio tumesema type of maintenance, which can be digital or analog. So nimeka type of maintenance. So what do you expect? Now, okay, we can also argue in this manner. If you are using a modern maintenance form, installation time itakuwa kidogo, sivyo?
Yes.
Na kama ni analog itakuwa mingi.
Itakuwa mingi.
So what do? We have some breakdown, or we say this one, ama tufanye hivi. This one is for twende na moja. We can go one at a time. So twende na moja, twende na the direct relation. We go with digital, sivyo?
Yes.
We go with the digital, the rahisi. But if you turn an analog, then we expect negative. Na hapa ni positive. Therefore, we can conclude it is not economic prosperity. We go with the digital, sivyo? So I was saying part A ndio hii answer yake hapa. Already tumeshajibu. We are supposed to come up with a regression equation. Y is equal to 0.93050 plus 0.03876 plus 1.2627 x2. That is our regression equation. Number 2, find the missing values of XA, XB, XD, and XC. Si zote tumefanya zote? XD ndio tujafanya. Can I show you how to find XD? That one is in the ANOVA table. How to analyze the ANOVA table. So let me show you how to analyze the XD, sivyo? Let me show you how to find XD. XD na XE. XD and XE, because that one is also important. But we tuko bado kwa process. Tuko bado kwa hizi process. So bado hatujafika kwa ANOVA. Tuko kwa ANOVA, yes, but because we can make this test using the ANOVA and the regression stuff. So we are within the regression analysis and the ANOVA. But when we talk about economic prosperity, mostly tunaongelea about regression analysis. But we also need to do the ANOVA. Now, before we do the ANOVA, before we go to ANOVA itself, let me show you how to find XD, because already it is there. So let me show you how to find XD. So allow me to rub this one. So hiyo sasa nikawa tunajibu tu yote mara moja, of which it was not my idea, but kulingana venye wameset hiyo swali, hizo value we need them. So lazima tu tungetafuta. So either way it is good. So huko mbele tukipeana formula, utakuwa unakuja unaangalia hapa nyuma yenye tumefanya, then unaangalia if we did the correct format. If we did what is correct or what is required. Pen ya black inasumbua sana. Now let's find XD. XD and what else? We have XD and XD. Now let's go to another table. We have the XD. Now for you to get the XD, this is the formula. Now XD is the MS, mean square. Sometimes unaweza umetumia the word MSS, mean sum squared. So mean squared or mean sum. So mean sum squared. So it is equal to mean squared or the mean sum squared. Mean sum squared. Now, how do we get it? So the mean squared is equal to the sum squared. Sum squared. So let me write it in full. Sum squared, which is SS. Can you see it? Nyuma yake hapo, you divide it with the degree of freedom. The degree of freedom. So degree of freedom. Now itakuwa ngapi? So let's find it. So what will be the answer? Yes. Someone to give me the answer. Yeah.
4.5.
9.0009. 9.0009 divided by 2. Itakuwa ngapi? 9.0009 divided by 2, which is 4.5. 4.5. 4.5. 0045. 0045. 0045. So that one is XD. We also need to find. Now, we also need to find XE. Now, XE is that one is for the residue. So it will be same as saying. So remember, this one is for the regression. This one is for regression. We also need to find the MS, which is MSS for residue. For residue, which is given as SS over degree of freedom. Now, in this case, wametupatia degree of freedom na wametupatia XE. Ala wametupatia MS 20.2107 must be equal to, so must be equal to, we don't know XE. You divide it by the degree of freedom is 7. The degree of freedom is 7. So what will be our value of XE?
$1.4749.
Yes. 1.749. 1.749. And that one represent what? They represent what? The mean squared of the both item. Now, we have done part A as find the regression equation. We have seen. Part B, we have done all the figures. So this is the formula. So write it down. So this one is for residue, and this one is for the regression. Now, if you go to our equation palette for ANOVA table, let's go to ANOVA table. Do you see the word source? So from the word source, chini yake We have the regression and we have the residue. We have the regression and we have the residue. I hope you can see that one. So we have the regression and we have the residue. So if you need to find the figures, you need to consider the one for regression and also the one for residue from the ANOVA table. So tumefanya part A na tumefanya part B. Part C. Now let's continue with our test. So you are in the reliability test, and we started with number 1, economic possibility, and that one is over now. For now, we can see this one is over. So we need to check the relationship which exists between the variables, what we expect and what is the actual, and then you give your comments. So that's how you do it. For economic possibility, haina mambo, you just take the equation and what you expect. If it is the same, then you say it is economic possibility. Now, if it's the opposite of what we expect, then you can conclude and say it is not making economic sense. Number B or number 2, you can decide to use number 2. Goodness of fit. Goodness of fit. Goodness of fit. Now, for goodness of fit, this is the test done to confirm that the equation fits the data. So this is done to confirm that the equation fits the data. That the equation fits the data. So it is done to make sure that the equation fits the data. So this, let me write it down. This is the test done to confirm that the equation fits the data. That the equation fits the data. So it's a test done to confirm that the equation fits the data from which it was derived. Now, we have several of them. Number 1. So what are some examples of goodness of fit? Correlation of determination. Correlation of determination. Now it is R squared. R squared. Now from our question, alikuwa amesema mbona kuna R squared. Nione kama alikuwa amesema mbona R squared. Part 3. Yes. You are supposed also to explain the R squared. The R squared. Now pale juu kwa ANOVA yetu, not kwa juu ya ANOVA. Between ANOVA and regression analysis table, we can up between. We have the S, that is standard error. We have R squared. That is what we need to explain from part 3 for R squared. And then we have the R squared adjusted. Now, for now, we are interested with the R squared only. Now, let us define it. What is it first before we explain the equation here to part 3. Now, it shows how well variable X explain Y. So, it shows how well variable X explain variable Y. So it shows how variable X explain variable Y. And then we write, let us write, I'm not sign a dictate. Let me dictate. Point number 1, we have only 3 points. Number 1, any relationship more than 80% is acceptable. Any relationship more than 80% is acceptable. So any relationship more than 80% is acceptable. Number 2, any relationship below 60% is not acceptable. Any relation below 60% is not acceptable. So tumesema ya kwanza, any relationship more than 80%. So any relationship more than 80% is acceptable. Number two, any relationship which is below 60% is not acceptable. And then ya mwisho, any relationship between 60 and 80%, any relationship between 60 and 80% is acceptable, but with some risk. So any relationship between 60 and 80% is acceptable, but with some risk. Now this is the formula. R squared. So let me write it here. Let me write it here. So R squared, this is how you get R squared. R squared is equals to summation of y predicted. So yn means y predicted. So for QA, those who did the QA, they know what is yn. Yn is y predicted minus y bar. Y bar is the mean of the y. Y bar is the mean of the y. Then you divide it by summation of y minus y bar squared. Can you get the R squared? Which is the same as saying, so I prefer the second one. Explain variation. Explain variation. Explain variation. We divide it with total variation. Total variation. Now from our question, what is the value of R squared? So from our equation, from our question, 85.94, 89.54%, 89.54%. Now we can determine this one. Now assume hatujapatiwa. So how do we get it? So tunasema it is explained variation over the total. Now let's go to ANOVA table. Let us go to our ANOVA table. Now, our explained variation is SS. Can you see the SS? So this one is the SS. So the variation is the SS. So come on, SS. Now, we have explained and unexplained. When we talk about explained, we mean regression. We talk about the regression. But when we talk about any unexplained variation, we talk about the residue. So make sure you know the difference. When we talk about the unexplained, remember that in SS. Remember the SS. So tunasema, when we talk about unexplained variation, we are talking about the SS for residue. So unexplained variation is SS for residue. When we talk about the explained now, variation for SS is the regression now. Now from our question, Captain. So what will be our explained variation from our ANOVA table? For the remember explained is the regression for SS. Mtu mwingine. No, call ama Nicole Palmer. Who call ndio nani?
9.0009.
Kumbe ni wewe. 9.009. Aya, total variation ni total. Both the summation of unexplained and explained. 0 ni tatu. 0 ni tatu. Sawa Cole Palmer. Aya, total. Total ni hiyo chini yake ukiadd hizo mbili. 10 point. Utapata Africa which is around 0.895. Something hapo. So it's the same. So hata kama imesaidia na Afrika kama moja, it is the same way. Hapo tuko sawa?
Question.
Yes.
Sasa kupata hiyo XE.
XE.
Tungechukua hiyo total to minus a regression.
XE gani hiyo sasa?
XE.
XE tunataka tafuta ama?
Na nauliza hatuwezi chukua hii ya total to minus hii ya regression.
Hapana, inafaa kuwa ni total. Unachukua hiyo SS ya regression, hiyo 9.09. Una add XE ndio kupatia total. Hebu add uone inakuja the same figure hapa chini 10.476. Hapo round hapo. Inakuja ngapi?
Iko around hapo, iko sawa.
Ni kwa sababu sisi tunatumia calculator. This one was derived from our computer. So computer may consider a lot of decimal points.
Okay.
Yes. So itakuwa around hapo. Haina shida. So unapata inafika tu na maybe 0.1 ama 0.2, which is not a problem. Now, how do you explain it? Let us explain this now. This is how you explain. So to explain part 3, the part of r squared. This is how you explain it. And we say that 84.9% of the iteration time is explained by the amount of maintenance and the type of maintenance. So you can say, so this is how you explain it for part. So hapo ni tatu. So mimi nimeanza na r squared. Tunasema 89.5% of our variable, which was installation time. Installation time is explained. So 89.5% of the installation time is explained by the month of maintenance. By the month of maintenance and type of maintenance. So that's how you explain that part. So 89.5% of the installation time is explained by the month of maintenance and the type of maintenance. And the type of maintenance. Any question concerning that one? So that's how you interpret. So walikuwa nataka kuangalia the interpretation yako. So hiyo ndio wangekupatia marks. So how many marks to start? So tumefanya kamoja. Walikusema ni marks ngapi? 6. So kwa r squared hapo anapatia 2 marks. Then the rest standard error na F statistics also 2 marks. So for this one is enough. So 89% of the installation time is explained by the month of maintenance and the type of maintenance. Now that's number 1, coefficient of determination. Number 2, standard error of the estimate. Number 2, standard error of the estimate. Standard error of the estimate. Standard error of the estimates, which inakuanga ni SE. So divided by SE. Standard error of the estimates, which is donated by SE. Standard error of the estimates. Now, we'll talk about the standard error of the estimate. Let's go to our equation part 2. Part 2. Standard error of. Now, part 2, qualification analysis, that is standard error of coefficient. But since we're getting about standard error of the estimate. So we have 2 types of error. We have the standard error of the estimate, and we have the standard error of the coefficient. Now, part 2, let us go part 2, qualification analysis. Now it is clear that we can see we have been given the standard error of the coefficient. But since we are instead the standard error of coefficient. Now, chini ya hiyo table, do you see the value S 0.49459,048? Can you see this figure? Anasema S 0.45909. Sijui kama ni hivyo. 0.449. Sijui inaonekana 0.459048. 048 hapa. Can everyone see that one? Everyone anaona hiyo?
Yes, sir.
Now iko hapo chini between and over table na hiyo table ya juu regression. Now let us define what is the standard error of the estimate before we talk about that figure yenye tumepatiwa hapo. Now this is what we can say. Let us write the standard error of the estimate, which is S3. It shows us the amount of error you can make after relying on the model to predict. So refers to the amount of error we can make after relying on the model to predict. After relying on the model to predict. After relying on the model to do what? To predict. So the amount of error that we can make after relying on the model. So they show the amount of error we can make after relying on the model to predict. Now, how much error shall we make if we rely on that equation? It is what we call the standard error. Now, this is the formula for standard error. Standard error is equals to summation of y minus yn squared over n minus k. Now, what is n and what is k? Yes.
Sample size.
Now, n is the total number of variables under investigation. Then k is the number of calculated variables. Number of calculated variables. For example, kama equation inakaa hivi, y is equal to a plus b1 x1 plus b2 x2. Then k will be equal to 1, 2, 3. The number of calculated variables are constants. So that is what we call the k. So that is the calculated values. N is the total observation. Now, this one is called, you can find it by, you find the square root of unexplained variation, unexplained variation, unexplained variation, unexplained variation. You divide it by the residue of the degree of freedom. Residue degree of freedom. Now, what is an unexplained variation? Remember, we said unexplained variation is the residue. So unexplained variation kwa our question ni ngapi? Someone tell us. Unexplained variation, that is SS, but unexplained. That is the XE. The XE, mlipata ngapi as XE?
1.4749.
That is unexplained. 1.4749. What about the degree of freedom of the residue? Ni 7. Degree of freedom is 7 of the residue. Kwa lower table pale chini.
Yes.
Yes. Now, find the figure unataka utapata at least figure inaenda na 0.459. I'm waiting for your answers. Jane hajaongea bana. Rada. Atujibie bana. Ama captain atujibie. Ama Kinyanjui sana sana. So we have about 20 minutes. So the class was to end at 12:30. So we are having about 20 minutes. So mnapata answer gani? Inakaribia na hii yenye tumepatia kwa swali.
Iko sawa. 0.45902.
Iko sawa. Yes, call Palma.
Cold as you like it.
So let us explain this one. Now allow me to rub on the other upper part so that we can explain what that error means. So that we can explain what that error means. So far not bad. So remember, hizi test zinakuanga sita. So far tuko kwa ya pili. Goodness of it. So tunaweza kumaliza kweli? Okay, we shall fix a time within the week. Ama tupatane hata kesho. Kama kuna mtapatikana. Uniona. Now, this is how we can explain and say, let us say, the predicted value. So we are explaining the standard error. This one. The predicted values using the equation will have an error of plus or minus 0.54459. 459. So that we have explained that one very well. We have explained that one very, very well. So that's number 2. For goodness of it, standard of error of the estimate. Now, should we talk about it? But we don't have the predicted value. But let us just write it interval. Na interval. But in case you have been told to find the interval using the standard error, this is the formula. So the data sorry is at last interval. So interval estimates. Remember, we are still under standard error of. So this question, we cannot find the standard error of the estimate because we cannot predict. But by how much do we need to predict? But remember, for us to predict, we need yn, which is the predicted value, plus or minus t statistics 1 minus alpha over 2. Tunafanya swali next time tukikutana. And then n minus k, then you multiply with the standard error. Then you multiply it with the standard error. That's how you find. So this one is at 95% interval. At 95% interval. Mostly. So kumaanisha hapa itakuwa ngapi? Our alpha hapa itakuwa ni 0.05. So itakuwa 0.05 divided by 2. But here tutafanya swali which has an interval. According to this question, we cannot do because hajatuambia any part that we need to do what? We need to predict. Let us go to the last one so that we can call it a day. So that tomorrow, not tomorrow, the time we shall meet again, we can start from the fourth one. The fourth one, the third one. Okay, tuangalia. So fit, read the F test. F test. F test. Now, according to that question, ukiangalia wametuwapatia F value. Can you see the F value? So F value ni ngapi? According to the swali. Enda hapo kwa swali. Part 3. Required part 3. What is the F?
21.36.
Yes. Now, that one is the F critical. That one is F critical. Now we need to find the F calculated. So we need to find the F calculated. Now, so for now, nitaonyesha kila kitu, but wakati wafanya swali nyingine, I will not do everything. But for now, I shall show you. So number 3, still under goodness of fit, number 3, F test. So what is the importance of the F test? What could be the importance of doing this F test? Now it is used to show whether the relationship is significant or not. So it is used to show whether the relationship is significant or not. Now we need to see if the relationship is significant or not. Number 1, we state the hypothesis. So we state the hypothesis. So we have HO and HA. Now what are our variable? So we say number 1, the relationship between y, x1 and x2 is not significant. It's not significant. Remember what it says? Remember y ni yours installation. X1 it was G type, the other one was G nini. It's not significant. Number 2, the null, we say the relationship between y, x1 and x2 is, now we say it's significant. Is significant. I think that one is fine. So the first one is if we accept the null hypothesis, then it is not significant. Then if we reject, then you can say it is significant. Step number 2, we determine the level of significance. Step number 2, we determine the level of significance. Step number 2, we state level of significance. How much significance? And this in case 75%. So we say it's 5%. So our level of significance, we conclude and say we shall use 5%. Step number 3, we do the test statistics. Step number 3, we do the test statistics. Test statistic. In this case, we need to find the F calculated. F calculated. And in our question, do we have the F calculated? Let us see. Yes. Let me see. Yes, 21.36. Do we find it? So how do we find F? Someone remind us the F. How do we find F? Let me see. Yes, nimekumbuka. So you need to find, you take the MS of the regression, you divide it with the MS of the residue. Now let's go to our question panel. So what is the MS of the regression? So MS of regression, we have 10 minutes. So MS of regression is happy. Someone tell us. XD. Prepare XD kama ngapi?
4.5.
4.5, 0045.
Yes.
Yeah. What about the other one for residue? 0.22107. Now, are you getting the same answer? Approximately the same answer? 21.36. Yes.
Yes.
Are you getting the
Yeah,
same?
yes.
Umeingia maji? Yes. Nimesikia Prezo Fernandez.
Bukayo Messi Saka.
Yes. So mnangoja build up. Bukisoma.
Bana ni wewe umetuweka bana.
Watu wa Chelsea ndio naona wamejaa. Haya. Let us continue tumalizie. We are about to finish. We have some few minutes left. Now we need to find now F. We need to find F critical. Now this one we go to our table. Now before we go to our table, ukienda kwa table yetu, our table yetu inakaa hivi. Utapata hiyo table inakaa hivi. We have V1 and we have V2. Inateremka hivyo. So we have two item hivyo. So this V1, it is N minus K. Then this V2, it is N minus 1. Now, what's our N? Total, the 9 minus, which is 8. So tunaenda pale kwa degree of freedom. Tuko na 2 na 7. Then hapa itakuwa ni 7 minus 2 because we only have 2, but we got 2 variables. Hapa anasema ni 2. So tunaenda na hiyo ndio anasema 5. So unaenda kwa table yetu, unaenda juu, so na unaenda kwa two tail. Do you have the table? Uko na table? Compass paper, do you have the table?
Hapana.
Amna this table, F distribution table. Na compass paper hapa waliweka.
Walisahau.
Walisahau. Sasa swali ungefanya aje? Hiyo ya F test. Now you need the table. I think maybe kwa the main exam ilikuwa. Maybe wakati waliweka hapa wako include. But in the main exam maybe ilikuwa. Let me see if you have any other F. So we need that table. Now, kwa past paper, hizi past paper hii ya eme waekangi hapo nyuma. So you need to download. So but in an exam lazima ikuwe. So in an exam, they need to provide if wameleta swali ya F distribution. Now we need to find the F critical. So we need to find the F critical. And in this case, tutafanyaje? Hamna hiyo table, always download. Just go and kwa net andike F distribution table PDF, then download it for the purpose ya illustrate. So like I'm giving you 3 minutes. So in next class, make sure you have that table. So F table, T table. So F na T. F na T. Aya, if yangu inakaa hivi, but hii zionekana. Mimi niko na hii. Haiwezi onekana. So that one is mine. So ukiangalia hapo juu kwa hiyo table, we have the V1 inaenda hivyo. And for 5% significant level. So make sure you download the 5%. So there's a kuna ya 10%. So but we there's pia ya 1%. 1% significant level. So sisi tunaenda na what we have stated here. 5%. So make sure you download your 5% significant level. Now, kwa hiyo table yako kisha download, unaenda mpaka ufike kwa 5. Na hapo unateremka mpaka ufike kwa 8. So hapo zinakutania. That is the figure of the F critical. So hapo ndio the figure of the F critical. Naona Jeff amefanya mambo hapo kwa group ametuma. So unapata kama ngapi? Unapata ngapi? Mimi napata 3.69. So plus inakuwa plus or minus 3.69. So kama unapata hiyo
Yes, iko sawa. Yes.
Iko sawa. Now that is step number. So step number 1 tumesema you come up with the hypothesis. Step number 2 we set the significance. Step number 3 we count the test. Then step number 4 tukasema what? So step number 4 ndio decision rule. So hii F critical ndio decision rule. So tunasema decision rule. So 1 2 3 4. So step number 4 decision rule. Na tumepata 3.69, so plus or minus. F critical ni plus or minus 3.69. 3.69. 3.69. Now, you compare this 3.69 with 21. Now, where does it lie? Where does it lie?
We, mfanyia nini ubao?
Ubao. Ubao imesonga?
Imeinama.
Yala. Hiyo si ni maajabu. So itakuwaje? Class ishe.
Class ishe.
Acha tumalizie. Na sasa hii
Iko best.
iko sawa, inaonekana.
Iko sawa.
Okay, okay. So tunasema for us to make any decision, we need to consider what? We need to compare this figure. So now figure hapa. Plus or minus 3.69. Unaiona? So you compare this figure na huyu. So F ratio, this is the F ratio or the F critical. You compare with the F calculated. Now, so E F critical ni plus or minus 3.69. Now the question is 21.36. Pick on which side? On the left side or on the right side? Is it on the left or on the right? Yes?
On the right.
On the right. So we do what? We reject that hypothesis. Now, what does that mean? Interpretation. What happens when we reject? The variables are significant. Now, when we reject, we mean that our variables, so we explain the relationship between y1, x1, and x2 are significant. Now, that marks the end. That marks the end of our class today. We can continue from there. Any question? Captain? Captain ana swali?
Niko bie. Niko sawa.
Iko sawa na Palma?
Iko sawa.
Vidi Palma. So we continue from number 3 as the goodness of it in the next class.